Today we're on pages 158 and 159. Have your calculator handy. Geometric series. Remember, a series is simply the sum of the terms of a sequence. Our first exercise, given a geometric series defined by the recursive formula a sub 1 equals 3 and a sub n equals a sub n minus 1 times 2. So the current term is equal to the previous times 2. Which of the following is the value of s sub 5? That's the sum of the first 5 terms. First term is 3. The second term is the previous times 2. 3 times 2 is 6. The third term, the previous times 2. 6 times 2 is 12. The fourth term, the previous times 2. And the fifth term. So the series is 3 plus 6 plus 12 plus 24 plus 48. That's 30, and 60 is 90. I'm getting 93. Now, there is a formula for the sum of the first n terms of a geometric series. The following is the steps in deriving the formula. I'm going to go through this. If you find it too complicated, you are more than welcome to just kind of skip this portion. So fast forward ahead to the next page. Write the explicit formula for a geometric sequence a sub n form. So in other words, a sub n is equal to a sub 1 times r to the n minus 1. Write out n terms of the sequence by plugging in 1 through n. Okay, so that would be a sub 1 r to the 1 minus 1, a sub 1 r to the 2 minus 1, a sub 1 times r to the 3 minus 1, all the way up to a sub 1 times r to the n minus 1. And let me just, so this would be a sub 1 r to the 0, and this is a sub 1 r to the first, a sub 1 r to the second, a sub 1 r to the n minus 1. Write an equation s sub n which gives the sum of these terms. Okay, so s sub n is equal to a sub 1 plus a sub 1 r plus a sub 1 r squared plus a sub 1 r to the n minus 1. Multiply both sides of the equation by r. Alright, so times by r times by r. So we have r times s sub n equals a sub 1 r plus a sub 1, so each term here is being multiplied by r. So a sub 1 times r is a sub 1 r. A sub 1 r times r is going to be a sub 1 r squared. A sub 1 r to the power of 3. Plus a sub 1 r to the n. Find in simplest form the value of s sub n minus r times s sub n. Okay, so I'm taking this here in blue, s sub n, so this minus this. Alright, oh, so look what happens here. Like this minus that, they go right out. Same thing here. And a sub 1 r to the n minus 1 will subtract out the one before it. So this is what we are left with, right? So it looks like we are left with a sub 1 and plus a sub 1 r to the n. Write the left-hand side of the equation in its factored form. All right, so this here, there's a s sub n that is common to these two terms, so we factor that out. This is s sub n times 1 minus r equals a sub 1 plus a sub 1 r to the n. From the equation in step 6, find the formula for s sub n in terms of a1, r, and n. So in other words, solve this for for s sub n, get rid of this 1 minus r. So we're just going to divide both sides by 1 minus r. And we have s sub n is equal to a sub 1 plus a sub 1 r to the n divided by 1 minus r. And that is the formula. And there it is on the top of the next page, where that came from. Okay, so for a geometric series defined by its first term a sub 1 and its common ratio r, the sum of the n terms is given by s sub n equals, and there's two versions of their equivalent. You don't memorize. This version is on the formula sheet. Okay, this is on the formula sheet, but you do have to be able to apply it. Which of the following represents the sum of the geometric series? So we're looking for sum of n terms, or sorry, 8 terms rather, whose first term is 3. And his common ratio is 4. All right, so we have everything we need. We need the number of terms, n. We need the value of the first term and the value of our common ratio. Substitute into the formula. I'm going to write down the formula first. So the sum of the first 8 terms is equal to 3 minus 3 times 4 to the power of 8 divided by 1 minus 4. Put that whole thing into the calculator. Don't try to do it piece by piece. So alpha y equals 3 minus 3 times 4 raised to the power of 8 divided by 1 minus 4. 65,535. Exercise 4, which will find the value of the geometric series shown below. Show the calculations that lead to your final answer. Well, first thing you notice is how many terms are there? What does n equal? How many terms? We don't know. We have to figure it out. We know the first term. First term is 6. And what's the common ratio, or the multiplier? We're multiplying by 2, so r is 2. Use our formula for a geometric sequence. A sub n equals a sub 1 times r to the n minus 1. 768. What number term is 768? All right, we're solving for n there, right? And n is part of an exponent, so we want to get that base and exponent by itself. So we divide by 6, both sides. $128. And then we could switch to log form. Log base 2 of 128 equals n minus 1. And log base 2 of 128 is 7. Add 1, n equals 8. So all that work just to arrive at what number term that is. So we're finding the sum of the first 8 terms, and then just substituting into the formula above. A sub 1 is 6, minus 6 times R is 2, N is 8, 1 minus R. Again, the whole thing into the calculator. $1,530. A person places a penny in a piggy bank on the first day of the month, 2 pennies on the second day, 4 pennies on the third day, and so on. Will this person be a millionaire at the end of the 31st day of the month? Okay, so that's what we have here. We've got 1 penny, and then 2 pennies, and then 4. So we are doubling each time, then 8, and so on, up into 31 days, so n equals 31. R, 2, and we know the first term is 1. Substitute into the formula above. Shouldn't end up with a negative, because I put the a plus instead of a minus. I did that in the calculator and also on my paper. Let's correct that. Okay, so these are pennies, all right? So that means if I divide it by 100, this would give me dollars and cents. So this would be 21474836.47. Sure I didn't miss any digits here. 7483647. Okay, so 3. So it looks like, oh yes, $21,474,836.47. Yes, definitely would be more than a millionaire. Over $21 million. Exercise 6, you're offered a job that pays a salary of $51,000 the first year and a 2% increase in each successive year. You decide to accept the job. What will your salary be during your 10th year of employment? All right, so this is strictly a sub n equals a sub 1 times r to the n minus 1, and we need to figure out what the value of the 10th term of this geometric sequence is. What is the r value? Well, if you're increasing by 2% each year, so let's say we start at 51,000, and then the next year you're going to be 51,000 times 1.02, and then the following year is going to be this times another 1.02, so it would be 51,000 times 1.02 squared, and so on, until you're at the 10th year. So R is 1.02, and 10 minus 1 close my parenthesis there, and now raised to 10 minus 1 is 9. So $60,949.72. You work 10 years for the company. What are your total earnings? Okay, so then in this case, it's asking us for the sum of your 10 years of salary. So S of 10 is going to equal, let me take a moment and just write down the formula. So S of n equals a sub 1 minus a sub 1 r to the n divided by 1 minus r. Make the substitutions, go to the calculator. $558,435.77. And then our last question, Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually. Maria would like to determine how much money is in her account after she had made her $500 deposit at the end of the 11th year. All right, so $500 to start with. At the end of each year, and that would have earned 5% interest, so times 1.05. Right. Looks good. 500. Then the second year, 500 times 1.05 was 500 times 1.05 squared, and so on. So really, this here represents the initial $500. All right. So this kind of sums up backwards. This is the first $500 she put in at the beginning of the first year. And that is in there for 10 years and earns this much, all right? And then it goes backwards. So then at the beginning of the 11th year, when she put $500 in, it doesn't earn any interest. Okay, now summing these up, this is the sum of the first 11 terms. And our first term is 500 minus 500 times our R value raised to the n divided by 1 minus R. $7,103.39. And this concludes the video. Thank you for your attention.